Welcome to this series on internal assessment. What I'm doing here is I'm trying to answer all these questions. If you go to the forum, you're going to see that there's heaps and heaps of questions. So if you go to IB Survival and you go down and look at what are the questions all about here. IA guide, failed results from my IA, Chemistry IA, what defines an IA. You can see that by far the biggest questions that students have are to do with internal assessment, and even if you go to the special website that only IB teachers have access to, you get the same thing. Even the teachers are asking IA. So what I've decided to do is show what I do for IAs. I'm just going to go to my Google Classroom and I'm going to just pull up the IAs from my students and just show you where I'm at. Now these resources here I'll make available on my website. I'll just put them there. I'll put the links to that in the description. And this template especially, IB doesn't like templates or checklists, but I have had this checked by a very experienced IB internal assessment examiner. We've gone through this and these are really the main things that you need to get, and I'll be working my way back to this quite often. So I'm going to put some anonymous reports out there. I'm hoping that all of you will watch it, and I'm talking to my students here. I'm putting them up anonymously. You're going to have to go and look at each other's and get good pointers from each other like I normally do in class. Okay, investigation on how much sodium in a drink. So, introduction, a little bit too much on just standard stuff that's not referenced. Let me just go to what we're really checking on is the data complete. Now, we have here range of data again that's discontinuous. It would have been nicer just to grab Supow and make 5 different dilutions of it. And even boil it down to make it more concentrated and see whether the method works or changes, if there's any inconsistency with how this conductivity works at different concentrations, see if the method itself is valid. This would be fine. It's discontinuous, it's not great. It's only 3 as well, which isn't great. We look for a range of 5 to see if there really is a relationship or whether it's just random. So the experiment's complete, that's what I'm looking for, but it could have been done better. So there will be some marks lost for design. It still needs to be cleaned up. What's the uncertainty goes up here, and what is it? What are the units? I don't know what this is, and to the power of 3. Units for seconds is S, not SEC. Just little things. So you need to fix that up here. So what have you got? Plus or minus 1 and plus or minus 0.1 on stuff. You should have had a standard. Oh, there's 3 separate tables too. Work out a way to get that onto one table so it's not so messy. I can't see where your standard curve is, your Beer's law, so how are you going to know what the sodium concentration is if you're not comparing it to something? Now I know you did it, just don't know where it is. So you need to put that in there, and that's how you're going to work out what the concentration of sodium is, because this must be the voltage or the current or whatever, and you need to explain that as well. Why did you go current, why did you go voltage, and what's been done. I need to see what research has been done, how's it been done in the past, and how's that changed from what you had done. So I'm getting off into the issues with the design now. There's nothing in here that tells me anything else. This is usually a repetition of introduction and method, but I need to see a lot more detail here to get all the information I need. So you've got diagrams, which is nice. I can see you've used graphite rods. I can use a fairly sensitive instrument here. This is electrolysis, so there's going to be some pretty horrible things happening when you zap it with electricity. Alright, I need to see colors and pictures. Don't know if that's enough. I can see here from the data that there are drifts. Alright, so you really need to get into your chemistry, okay? What would have caused that? I'll be a little bit nice and wait till we finish topic 9 so you can really have a good understanding of what happens there. So let's just wait until we've finished that. It's nice to see that you've gone over some errors. Let's not worry about that too much. So I want to know why did you choose sodium, and is sodium the largest thing in these drinks? I'm pretty sure it is. I think we talked about that when we were designing it, but you've got to list where are the lists in your introduction of everything that's in these drinks, and so how much potassium is there, and how's that going to affect your error. So you've got some pretty nasty stoichiometry there that you can use to determine errors, or the machine. You've got to get some sort of uncertainty and accuracy stoichiometric calculations in here. This is good practice for your exam. Okay, so it's pretty scary. You've got to grab this data that you've got and you've got to convert that into some sort of understanding using Beer's law and stoichiometry to work out, well, what does that mean? What's the actual sodium concentration of that? And so amount of sodium in volts, it's not amount of sodium, it's just the volts. All right. So you've got some work here to sort of understand what your data is and process it before you can really make sense of this experiment. If you found that helpful, please like it and put some comments in the comments below, and please check out the other videos for more advice.